Hope you are fine. So today we are gonna solve the problems from LeetCode 75. So we have done with the previous topics, the first problem of the previous topics. Now today we are solving the first problem of heap or priority queue. So I hope you are aware of the heap. If you are not, then okay. Let's read about heap. So a heap is a tree-based data structure in which all the nodes of the tree are in a specific order, right? So let's read about heap. So every node, the value of its children is greater than or equals to its own, right? So that means every children every children has a value greater than the node. So that means ultimately the topmost value of any heap, right, is the minimum of the all the values. Topmost value of all the heap is the minimum of the all the values. So this is the min heap. We can also use to get the maximum value by putting the negative values inside this heap, right? So that means we will get the maximum value of all the heap, right? So generally we will get the minimum value of all the heap, all the elements present in the heap, or we can also get the maximum value of all the elements present inside the heap. So this is the heap, right? This is also the priority queue. The similar, both are the similar things. So so this is the question. This is the very standard problem. Kth largest element in array, right? So how to solve this problem? So given an integer arr and an integer k, then return the kth largest element in the array. So in this example we have to return the second largest element. So we can see the 6 is the first largest and 5 is the second largest element. So how can we solve this problem? There is a basic approach. So the first approach is which came in our mind is, let's sort the array and return the kth element from the last. Okay, so we will simply do this. What is the need of heap or priority queue or all these different data structures? So I'm not mad. Let's talk about this time complexity. So the sorting will only take time complexity of n log n, right? Space complexity is nothing but n, right? So n log n is a time complexity of sorting, right? Now just let's talk about the heap wala approach or heap approach, right? So what we will do, we will make a heap of length k, right? And inserting in heap of length k will take O of k, and popping out or extracting the data from heap will take O of 1, right? So we will second operation will be iterate through array and insert the element if that is smaller than the min. Okay, so we will make a max heap, right? And iterate through the array, and so max heap means the topmost element will be the maximum element from that heap, right? Or okay, so we will make mini heap. Sorry guys. So mini heap means the topmost element will be the minimum from that heap, right? And iterate to the array, insert the element if it is greater than the top element. Okay, so this will take so the operation will take in the, after the iteration, return the top element. So what I'm doing is I'm creating a heap and I'm putting, let's say, all these elements inside the heap. So this is a mini heap, right? So let's take this example, right? This is a mini heap. So heap is currently 2,3. The topmost element is the minimum element out of it. Now I am iterating through the 1, and if 1 is greater than 2, no. If 5 is greater than 2, yes. So we will extract 2, and okay, we will insert 5. 5 will be inserted back. So we will iterate. If 6 is greater than 3, yes. So it will be like this. If 4 is greater than 5, no. So the answer is 5. Okay. So what is the time complexity? Okay. So we are comparing with the sorting algorithms, right? So what is the time complexity? It is nothing but the n log k. So guys, we are not just decreasing this log n, but we are decreasing n into log n, right? Which is a huge difference. So as you can see, this is the 10 to the power 5. So log n, the n log n will be something 10 to the power 8, but k is generally small, of course. So that may make a huge difference. That must make a huge difference because k is a small number. Okay, so also what we can do, so if k is smaller than k is greater than n by 2, that means we have to find element, like if n is 1 2 3 4 5 6 and k is 4, so we have to find the fourth biggest element. That means we have to find the second smallest element. So we can also make such type of algorithm in which if k is greater than n by 2, so we will reverse this problem into the finding smallest element, right? So that will make this maximum time complexity from n log n by 2, which is a huge difference. So fine, now let's implement this problem. We will create a heap in Python. Heapify. Okay. So we will make heap q.heapify. Heapify nothing but this. We'll make an empty heap, right? Okay, so not an empty heap, but the initial k elements from the nums, right? Initial k elements from the nums, right? For I in range we'll start from k and length of nums. What we'll do, we'll make m is equals to min from nums I, comma heap pop. So we will make h is so h is nothing but nums k, and so we have to create a list and we have to heapify this list, right? And heap of h, and what is this 1 2? Okay, so we are just popping from h, and we will heap push so m, right? So this is not min but max, right? Because we have to make max, right? And we will return heap of h. So let's see if it is working or not. So heap push, okay, h comma m.
हाँ जी,
सर मैं एक मिनट में आता हूँ।
मीटिंग चल रही है?
नहीं
आज करो फिर।
हाँ बिल्कुल
ठीक है, फ्रस्ट्रेट होने लगे हैं। ठोको यार, कुछ पता चले सक्सेस फेलियर जो भी है जो सामने तो
हाँ